Hey everyone, in this example we're going to solve this system of equations with Gaussian elimination. Note that we have 3 equations and 3 variables. So trying to do this with algebra and substitution and elimination would be really messy. So we're going to move to matrices. And our process is to get this into row echelon form and then read the solution from that row echelon form. So our first step is to take that matrix and to put it into an augmented form, which simply means take the equations and their coefficients and put them into an augmented matrix. So for example, up here in the first equation, you see that 1x minus 2y plus 1z is equal to 3, corresponds to the 1 for the x, negative 2 for the y, 1 for the z, and 3 for the constant. And the other 2 rows are basically the same. So our goal is to turn this into a row echelon form matrix where we have 1s along the diagonal and 0s below it. Keep in mind, we're going to go 1 column at a time. Let's start. Our first step is to make this leading position a 1, and it already is. So no row operations are needed for that. So now we move down to this position and we want to make this a 0. So we can't multiply this by a non-zero constant and get this to be 0. The only way to make this entry a 0 by multiplying by a number would be to multiply by 0. But if we did that, we would zero out the whole row. Sorry about that. We would zero out this whole row, and we really don't want to do that. So we're stuck with going with row operation number 3, where we have to take a multiple of another row and add it to the existing row, and then put that into row 2. So notice I have to add something to a 2 to get 0. Of course, that number is a negative 2. So I say, if I come up here to the 1 in that leading position for that column, what would I need to multiply 1 by to give me a negative 2 that I could add to this 2? And of course, the number I need to multiply by there is a negative 2. So I'm basically going to take row 1, multiply it by a negative 2, which you can see I'm going to annotate this way over here on the left of the matrix. Then I'm going to add that to row 2, this entry, and I'm going to put that into row 2. So I am replacing row 2 only. Rows 1 and rows 3 are not going to change. So I recommend you always rewrite the 2 rows or any other rows that are not changing as your first step in this process, and then fill in the row that is going to change, which in this case is row 2. So we'll do one entry at a time. This entry here is going to come from taking negative 2 times the entry in the first column and then adding row 2 to it. So negative 2 times 1 is negative 2. Negative 2 plus 2 gives me 0. For the next entry, I move to the second column. So I do negative 2 times the entry in the second column. So negative 2 times negative 2 is positive 4. Positive 4 plus a negative 3 gives me this entry, which is 1. Moving to the third column, negative 2 times 1 is negative 2. Negative 2 plus 4 gives me positive 2. And finally, negative 2 times 3 gives me negative 6. Negative 6 plus 2 gives me negative 4. So I've done what I accomplished, which is to get this entry to be a 0. So I have a 1, I have a 0, and now I need to make this entry a 0 to finish off column 1. So let's move there. Again, we're making this entry down here a 0. Again, we're back to row operation 3, because swapping rows is going to mess up putting the 1 up here, and it's going to potentially mess up having the 0 here. So row operation 3 is the only thing that's going to really work for us here. I need to add to 3 something that will give me 0. And of course, that number is negative 3. So how do I get a negative 3? By multiplying by this row up here, which is where the leading 1 is. I have to multiply this row by negative 3. So that's what's going to happen. I'm going to take negative 3 times row 1. I'm going to add that to what's in row 3 now, and I'm going to replace row 3 with my result. So the only thing that's changing here is row 3. And I'm going to get there by multiplying the first row by a -3. Since row 3 is the only thing that's changing, I'm going to copy down rows 1 and 2 very carefully, and then proceed to fill in these 4 entries. Starting with the first column, -3 times 1 is -3. -3 plus 3 gives me this entry, which is 0. That's exactly what I wanted. Now moving to column number 2. -3 times -2 is +6. +6 minus 9 gives me -3. In the third column, -3 times 1 is -3. -3 minus 6 gives me -9. And finally, in the last and fourth column, I have -3 times 3 is -9. -9 plus 24 gives me this entry, which is 15. So now notice column 1 is done. I have a 1 in the diagonal position, this leading position, and I have zeros below it. And so I'm going to forget about column 1 now. I'm moving on to column 2. So column 2 needs to start with a 1 in the diagonal or the leading position for that row. And you can see here it is already a 1. So that means no row operations are needed to make this a 1. Moving down now, I want to make this a 0. So I need to add something to -3 to get 0, and of course that's going to be a +3. What do I multiply 1 by to get +3? Obviously, it's a +3. So I'm going to take +3 and multiply by this row, which is row 2 now. So I'm taking 3, I'm multiplying by row 2, I'm adding to that whatever's in row 3, and I'm then replacing row 3 with the result. Again, because row 3 is the only row that's changing, the other 2 rows, 1 and 2, are going to stay the same, which is what I've done here. Just copied it right over. Starting with the first entry, we can go ahead and do this, but this 0 here is going to be preserved because 3 times 0 is 0, 0 plus 0 is also 0. Then I have 3 times 1 is 3, 3 minus 3 is another 0, which is exactly what I wanted. I wanted the 0 below this 1. 3 times 2 is 6. 6 minus 9 is -3. And finally, in the last position, 3 times -4 is -12. And then -12 plus 15 is +3. So we're done with column 2 now. I have a 1 in the diagonal position and a 0 below it. I don't care what's above the 1. I care that below the 1 is a 0. So columns 1 and columns 2 are done, which leads column 3. So moving to column 3 now, which is right here, I want this to be a 1 because I need 1s along the diagonal. Now here I can move to row operation number 2, which is to multiply a row by a constant and replace it with that result. So if I want this to be a 1, then I can multiply row 3 by -1/3. So -1/3 times -3 is +1, and that's what I want. And I'm going to take that result for every single one of the 4 columns and put it back into row 3. So when I do that, it's pretty straightforward. -1/3 times 0 stays 0. -1/3 times the second 0 also stays 0. -1/3 times -3 gives me +1, which is what I want. And -1/3 times +3 gives me -1. So column 3 is now done. I have a 1 in that position and only zeros below it, which in this case doesn't really apply. And I'm in row echelon form because I have 1s along the diagonal and zeros below those 1s. And all the numbers over here are going to be useful for solving the final solution of the system of equations. Okay, so that's basically our last step. Let's go to our row echelon form, which looks like this. And we always start by going to the bottom row because that tells me one of the values of the variables right away. Remember, this column at the far left is for x, the second one is for y, the third one is for z, and this is my constant column. So this is telling me that z is equal to -1. And so that's the first part of my solution. The second row tells me that 1y plus 2z, so 1y plus 2z is equal to this -4. But I already know that z equals -1. So if I put in -1 into this 2z term, 2 times -1 is -2, which gives me y minus 2 is equal to -4. And then if I add 2 to both sides, I end up with y equals -2. There's the second part of my solution. The third part comes from row number 1, which says that 1x minus 2y plus 1z is equal to 3. So x minus 2y plus z is equal to 3, but I already know that z is equal to -1, and I also know that y is equal to -2. So -2 times y equals -2 is +4. So I end up with x plus 3 on the left is equal to 3 on the right, and if I subtract 3 from both sides, I end up with x equals 0. And there is the final solution. X is 0, y is -2, and z is -1. So in point form, it would be x is 0, y is -2, and z is equal to -1. So this is the Gaussian elimination process. It will require some practice, so I encourage you to try as many homework problems as you can, regenerate them when you need to get extra practice. Once you get the hang of this, things go much more quickly, but you will need to very carefully practice these. Once again, I suggest you write these up very carefully. If we go back really quickly here to a good example of how to write up these things, you'll notice that you want to document every single step along the way. So if you're swapping rows, you use this notation. If you are replacing a row with itself added to a multiple of another row, you use this kind of notation, and so on. So get into the habit of showing this one step at a time on your paper. Do only one thing in your process at a time so that you don't get lost. And use pencil so you can erase. And if you have questions, you can post your handwork to the forums, and I can help try to find any errors that will help you to figure out what's going wrong if you can't get the solutions. So that's the video. I hope that's helpful. I know it's another long one, but to explain these things very carefully takes a little bit of time. So good luck with your efforts to learn this. I know you can do it. Hang in there and keep practicing. We'll see you on